Perfect. Well, welcome everybody to our ninth paper session, looking at the paper Sparse Rewards Can Self-Train Dialogue Agents. We'll start by just doing a really quick welcome and introduction for anyone who's here and non-AI and wants to say who you are. Then we'll dive quickly into a little bit of an overview of the theme, and then into the real meat of the different questions or ideas that came up for each of you in looking at the paper. So I'm Daniel Lindenberger. I'm helping out with these paper sessions at PolyAgent, and otherwise engaged a little bit with looking at AI workflows and how they can be designed for different organizations through our nonprofit. I will throw things over. And so what I hope to get out of this session is wider insight on this paper and on some of the different strategies that are being mentioned there, and your thoughts on where this may be applicable as really some interesting fine-tuning approaches that are there and some tools for improving fine-tuning approaches. I'll throw things over to Randall for an introduction.
I'm a person that's interested in healthcare and the applications of AI to healthcare.
Perfect. And Arthur, how about yourself? Who you are and
Sure. Founder of PolyAgent. For this paper specifically, I'm interested in the actual ideas of the reward models without the human feedback, and I'm very skeptic about that. So that paper was very interesting for me.
Perfect. How about you, Slava?
Yeah, I'm senior R&D engineer at Dutch Royal Academy of Arts and Sciences, and I'm interested. First, I'm building an application myself, and second, I'm interested in agents, of course. So this is why I'm here.
Perfect. Siddhartha, good to see you there. Do you want to introduce yourself?
Yeah, hi, I'm Siddhartha. I'm a bioinformatics programmer working in New York area. I was with CoronaWhy and now with PolyAgent. I'm interested in LLM applications, how we use some of these models in our work for protein structure modeling, but I'm also interested in other kinds of uses, especially if it relates to neuroscience.
Perfect, thanks. Hamza, do you want to introduce yourself?
Yes, hi guys. This is my first session. Pleasure to be here. I'm at Arthur at the Gain Summit, and he introduced me to this. Pleasure to be here. And I'm a AI project manager in Saudi Arabia for a company called Watat. And we're building large language models for the Arabic language as well as English bilingual models. So anything to do with generative AI, and you've got my interest. So looking forward to hearing and contributing in the next sessions as well. So pleasure. Thank you.
Fantastic. Looking forward to hearing more about your work with Arabic models as well. Jonathan, do you want to introduce yourself? I know this is your first session as well.
Yeah, it's an honor to meet you all. Jonathan Haber, my company's Next AI Labs, and yeah, we believe that you should have all the support you need to realize your full potential, and that technology is at a place where we can make that so. So we're working on training AI to support the actualization of latent human potential. That's such a fun thing to say. That's really fun to say.
Perfect. Osama, do you want to introduce yourself?
Yeah, sure. My name is Osama. Previously, I was with CoronaWhy here, and now PolyAgent. My background is in robotics, so this paper is really interesting to me to see how, in long term, it would compare to traditional reinforcement learning algorithms, etc. And so, yeah, looking forward to the discussion.
Fantastic. Anton?
Hi, everyone. My name is Anton. I'm on this community since CoronaWhy days as well. At PolyAgent, I'm responsible for compute. So if you have some experiments to run, you will probably check with me. I'm also excited about this paper because it combines quite a few interesting areas, including benchmarking. And I like that the authors mentioned that they paid attention to, was that Josh approach in terms of like fine-tuning their models, not to degrade the general reasoning. So that's kind of topic that I'm interested in recently as well for our stuff at PolyAgent. So interesting paper.
Fantastic. Alan, do you want to introduce yourself?
Hi, I'm Alan Jackson with Southern Arizona AI. It's a group of retired PhDs and engineers that get together bi-monthly and discuss AI topics. Yeah, it's an interesting article. Yeah, I look forward to seeing what everybody has to say about it. Thanks.
Perfect, thanks. And Tyler. Good to see you, Tyler. Dimly as it may be. While Tyler's getting audio going, I'll just quickly say that I know it takes a little bit of time to do these intros at the beginning, but it's also critical because these paper sessions aren't just about the paper, but it's a chance for us as a PolyAgent community to get to know one another. So what you hear about each other and what you say about yourself really helps give some of those different sort of bookmarks that people might have so that on Slack or otherwise they know who they might want to reach out to. About the different pieces everyone is working on. So thanks everyone for giving the introductions. Go ahead, Tyler.
Thanks, Daniel. Yeah, I realised that my mic was turned down. I was like, oh no, it needs to be on to work. Yeah, hi everyone. I've been involved with this various versions and iterations of this community since Corona Y days. I don't work in tech. I don't work in AI. I find it an interesting subject matter. I like to bring my sort of humanistic psychology interest around it and that kind of perspective. But I enjoy having interesting conversations around interesting things, and this particular paper was an interesting one this week, plus glancing through the other ones that were suggested. I don't always find time for it, but this week I've tried to make some space for it. I'm looking forward to hearing other people's thoughts.
Excellent. Eduardo?
Hi, hopefully you guys can hear me. I was having audio issues earlier. But yeah, I'm Eduardo. I'm the CEO and co-founder of Express AI. I'm also having video issues right now. Yeah, so Express AI makes a kind of like agent hosting platform. We kind of want to be like the Heroku of agents. You know, when I started when I started going in the agent direction in like 2022, I kind of hoped that GPT-4 would be a little bit better than what we actually got. And since then, I don't think we can kind of offer the level of service that we've been promising the users. So I've been mainly interested in how can we leapfrog kind of OpenAI in the agent space, making agents that can actually do really long-term, very complex tasks on our platform. And also in general, we are heavy open source contributors and things like that. So we want to kind of share that with everyone. And yeah, and so I just learned about this PolyAgent from a meeting that we did, I think in Google Tokyo. That was the first time I heard about it. So I signed up and this is my first paper reading session. So looking forward to, you know, interacting more with PolyAgent.
Fantastic. Well, welcome. It's nice to see that there's a bunch of new people joining in on these sessions. I believe
my global migration and events is definitely helping bridge some people from different parts of the world.
I think on our site we should have a "Where's Artur right now" sort of map, the real-time distraction.
Yeah.
Ivan, I think you're our last actual human who hasn't introduced himself yet.
Yeah. Hi, everyone. My name is Ivan Belenki. I'm from Argentina. I'm a nuclear engineering by degree, but I actually a practitioner of, I come from classical RL. And I'm just interested in the very broad way, so glad to be here.
Fantastic. I'll give just a brief summation that our agent came up with for the paper, and then we'll turn us loose on the different topics that are there. So, the novel self-improvement paradigm, juxtaposed outcomes for simulation harvesting, JOSH, allows agents to autonomously enhance their multi-turn dialogue performance without human feedback. By simulating sparse reward environments, JOSH highlights a future path where agents can improve themselves, making it a fascinating topic for fine-tuning in agent interactions. All right, I'll open the floor. I'd love to hear what people's thoughts were around this one, questions or ideas that it sparked.
I have a couple, but I don't want to go first because I'm new here. I want to see how this thing works, but please somebody go and show me how this thing works so that I can contribute also.
I'll say, for all the new folks, I'll say we're pretty diverse. It's a pretty wide spectrum that's here in terms of people's level of familiarity or zoom in of interest in the different areas that we might cover, and all of those different topics are welcome. Often we will dive into the sort of the ethics, politics, and realities around the different pieces. Sometimes we're getting into the nitty gritty around the specifics of the models or the systems or the architectures that we're looking at. Sometimes we'll talk about specific domains. I know, as an example, Siddhartha, anytime that you're bringing in the neurology to our conversations and some of those pieces, it's always fantastic. So really anything goes in terms of these conversations. We'll sometimes rein things in lightly, but not too much. It's meant to be a good opportunity to talk about whatever gets prompted from it. I'll start things off maybe by saying I thought it was really interesting in looking at preference fine-tuning in a backwards modality. And so I had been thinking about preference fine-tuning from sort of a human in the loop way. I don't know, again, like I'm pretty new to this whole area of fine-tuning. But doing a reverse engineered preference fine-tuning where you move from outcome backwards strikes me as interesting when you're trying to tune against human psychology, because the way that we as humans explore potential routes leads in a very different way. And I wonder how many different ways that humans try to navigate away from local maxima and into more optimal sort of areas of a problem space may be different from what you get when you try to reverse engineer those preferences in terms of the training values.
Yeah, you can't engineer too much when you eat the wrong plant and you die, Kind of
Fair
those
enough.
kinds of situations.
Yeah, well said.
Okay,
Yeah, so
I'll throw my oh, good.
go
Go
ahead.
ahead, please.
Go
There's
ahead.
a delay. Okay, fine. Be that way. All right, I'll throw my 2 cents in. I mean, I got a lot of 2 cents. I've only been digging into this paper for 10 minutes, but with AI, so that's like 8 hours of work right there. So look, it seems like a potentially breakthrough idea, even in the use case of my tech where we're simulating life coaching. Potentially ethical concerns, right? AI training itself, where's that going to go, right? So that's worth a touch on. Is it the most optimal system for what it's trying to do? I would say no, it could be improved. That's where I want to throw my 2 cents in. Take a use case of optimizing a meta ad for purchases, right? Not the funnest use case, but it's a perfect example. You could spend $2,000 optimizing an ad for enough purchase to have enough data for the reward mechanism to calibrate to what you're actually looking for, right? And so that's a downside of this approach is where do you set the goal for the reward? And then and it highlights the and that's not necessarily like a critique on the paper, right? The user needs to design what the rewards are, whatever your application is, right? But I think that I dug in this because that's exactly a problem I was working on. And I think a model for how to do rewards has to include penalties also, and this tech needs to account for that. Quick example, and also just sort of prorated rewards. Like the way that my current attempt at solving this is, you get a lead from an ad, calculate the value based on like how many of those leads convert, what's the dollar value of that conversion, you calculate that value down to the penny based on your actual conversion rates, and then assign that reward for each step up the funnel. And I think that's an optimization you could get from an approach like this, is to sort of identify the exact value of each step that is in fact progress. But there's a downside to it also, which we discovered in the harshest way. I nearly lost my company over this discovery, which is the sort of then the algorithm will optimize for values that lead to your reward center, which do exist. I found that through bot activity, which we were optimizing for without realizing it. They would click through and look around and we would optimize, that's progress. Right. So by the time you actually get to a reward that's substantive, then there needs to be a different reward that, well, ideally you would just then penalize everything that didn't go there, right? So you could actually get, that's the rough idea of what I'm thinking is like sort of an optimal thing. You've got penalties, you've got the ability to retroactively penalize activities that did not lead to the reward. And then you need to think about how to mute the reward values relative to the actual success of the goal. So if we do get a purchase, right, for $50, then all of the rewards we gave for a click that didn't result in anything, we need the purchase to outweigh the actual value of the purchase, so that the AI is calibrating a different order of magnitude, so that it knows to they're kind of stepping stone rewards that are somewhat muted, ideally. Did that make any sense? I hope that helps.
I just wanted to check. I just wanted to check my thoughts on that. So you're kind of talking about like A/B testing adverts, or how like, is this as effective as that? So all the different iterations of an A/B test kind of run through an agent simulator, and to work out if that's effective and the time spent on it and the money spent on it is worth it before you actually end up with real use cases and real users going through it. Is that kind of what you're getting at?
Well, that's what we did. Yeah. We trained the meta algorithm on every click, every landing page view, every 1 minute retention, 2 minute retention, click over to a checkout page, add payment, and we put values on each conversion so that we could train it faster than its default mechanism, which is pick one variable and stick to it. And most people do purchases, right, if that's what you want, but then they're wasting thousands of dollars on ads waiting to get that data of enough sales to basically train the algorithm. So we had to do that for that use case, and that's the example I'm thinking of. Yeah. And
I'm going to jump to Siddhartha in a sec. I just, it's interesting noting we optimize towards what we measure for, and that importance, like as you say, it's easy to over optimize, and you had a perfect solution for bots, which is exactly what you didn't want, but it's really easy to over optimize for. Relating to how the authors were talking about when you focus on inform rate and success rate overly, rather than looking at why are you doing that and what is that actually optimizes for. Siddhartha.
Yeah, hi. Yeah, thanks for those insights, Jonathan. Now, what I wanted to say is that it's just, the humans, like how we might be doing it. So there is this idea of a predictive coding, like the brain, there's a top-down brain, which is continuously predicting what the world is like, and the bottom-up is gathering all the information. So you can think of the bottom-up as one LLM that is like, summarizing what we see and presenting it to the thing. And there are multiple streams, right? Like there's a visual stream, this stream, that stream, 100 different streams. So there are two things, and there are like certain chemicals which sort of up the gain, like acetylcholine or something, but you forget it. Like suppose there are things that are upping the gain of certain channels, right? So the question is, are you, if when you have a ADHD, or when you're not able to, find something correctly, is it because a gain is not up, or a reward is not associated with the top-down thing? So the top-down is now going to associate a reward, because the bottom-up is just like summarizing what's there, and the top-down is going to evaluate each one and assign a reward. So yeah, so that was my thought, and I was wondering if some kind of a structure could be built, like where one kind of agent is doing based on what inputs are coming in, and the other one is just summarizing what's there. And there are the two factors, like should you are you incorrectly placing a reward, or are you incorrectly sort of upping the gain of something that's important?
Yeah, I would jump in and talk about how important is the actual reward design is from the perspective of the actual interactions, right? The paper focuses on highly structured use case, the actual tool calls and using APIs, which kind of works because you can get to a very specific result. It's quite binary. Either you code the right API or not. You may actually end up with real world situations where you can call the right API with different parameters. So that gets tricky. But it's interesting that I think the limitation of this approach, obviously, and my skepticism around it, is in the fact that real world situations are not just like API calls, right? So when you talk about the preferential training, and LLMs in general, and the agents that will be interacting with us in the real world, there's no, kind of like reward modeling that can satisfy for human interactions. Not always, sure, with like reservations and stuff, it's quite binary whether you get the reservation done or not, and maybe that will satisfy the subset of these agentic use cases. But for the plenty of others where the outputs are just text and no specific outcome, I don't think these methods without the human will work. But that's my thoughts on it. It was surprising not to see that in the limitations section of the paper, to be honest.
Well, and it's interesting. I mean, you think about the Abilene paradox when you talk about, getting to the successful API outcome, you get your sort of reward for that. But as they talk about in the paper, maybe you successfully got to Kentucky Fried Chicken, but you'd have rather gotten to Nando's, but you didn't give that option as one of the ones that was given. So the different ways that it's easy to sort of oversimplify what those rewards are actually getting and to miss what the subjective experience is that it's trying to capture.
Right, because what's the goal? To get some food, or to get the food that you like, or the food that you like and is healthy, or the food that you like and is healthy and is cheap. There's so many dimensions of the actual rewards that we as humans optimize for that are assumed or sometimes subconsciously decided.
Would that be short-term or long-term reward, sort of like?
Well, humans are very bad with long term.
Yeah, we're really not good at long term.
And it's interesting because that's such an opportunity with AI for ways for us to explicate what our long-term rewards would be, our long-term goals would be, and having AI augment our capacity to actually aim towards those. But that when we have reductive training that really is going towards the most simple of rewards, it precludes that.
I think that would be the case if we wouldn't be optimizing the agents to produce the Facebook ads, Not to grill you, Jonathan, but the current use cases that we're talking about would be very short-term oriented. Like, I mean, basically systems that would optimize for the consumers in a way that kind of goes away from what's good for the human.
Yeah, the difference between the consumer paradigm and the like member, or like the what's the word? There's a whole piece of research, the whole citizen paradigm, where it's something beyond just the buying and selling of things, and how like contributing to something bigger is slower and more nuanced. Definitely something AI can help with, especially guiding us in short-term decisions versus planning long-term and actually making them steps break down and work towards them, rather than trying to recall it and remember it all yourself.
And so partially, I think you turned us late, but feel free to jump in at any point.
Oh, I totally agree. Yeah. The meta example is the least inspiring of all examples. It was also the best to illustrate the point, so I'll use it. What I'm grinding on is harder to really understand, but we're supporting people in realizing their goals. And if you're doing that with tangible goals, objective goals, like buy a car, rent a house, get my dream job, it actually gets quite simple. But when you look at subjective goals, right, to be more present, to be happy, to surrender, to welcome life, right, as it is arising, that the quality of life, the stuff that really matters, right, in terms of like, who am I being in the world, then how the heck do you measure that? And I love that I had teachers in my life, I was so blessed, who actually forced us as students to figure out ways of measuring that. But that's actually sort of where the fun stuff is for me, grinding on this and then determining, so one of the challenges of this model, same example, right? But if you followed that, then you'll follow this, is, what's the difference between actual growth and perceived growth, right? Because you can have a positive state experience that makes you feel like you got value from some kind of inquiry but that doesn't actually enact sustainable change in your life. And so to what degree do we value that, or have the AI value that as a win, right? That's where my brain is is at. I last thing on this, I became quite masterful at teaching the computer to elicit novel states of consciousness. You wouldn't believe how gripping I got the computer to facilitate. But yeah, I was simulating AI before it was really available, as far as I know. But it wasn't creating change in my life. It was like these novel insights and states of consciousness and sense of awareness of what is the most aligned path. And then I would do nothing. I would turn off the AI and go play video games. So I knew there was something missing. So anyways, that's what I'm grappling with, is like, what do you actually measure, right? To actually determine the effectiveness of you know, in my use case, it would be in supporting somebody in the growth that they desire, right? Who they're being in the world. Ideally, that's the funnest part. Harder to sell, but really
Yep.
the most value. Yeah.
Yeah, what you're describing is I normally call productive procrastination, where it feels useful, but it actually isn't useful to the big picture. So it's like the idea of learning something because it's interesting, but it doesn't actually contribute to it. Something it like doesn't contribute to a bigger idea or something bigger. It's procrastination. You are procrastinating, but you're procrastinating in a way that feels productive. So it kind of tricks your brain into feeling like it's useful when it's not necessarily always useful. Like I am a king of productive procrastination. I can procrastinate better than most people and make it look like it's work when I'm just diverting myself from something I should be doing instead.
You know, Oscar Wilde said, I think that procrastination is a waste of time. So, but anyway, I actually wanted to say, I was wondering, like, you know, I haven't really gone into the details of this OpenAI's reasoning model that they have said. And I'm wondering is reasoning, like if you're predicting the future, is that the same thing as long-term predictions in some way? That a reasoning model be used for long-term predictions?
From what I can tell from the new model, it's very much doing the same thing that Claude and Anthropic is doing, which is that there is a keyword that the model can produce, and that keyword isn't shown to the user, and it just allows the model to spend more tokens thinking to itself, which is something that, you know, we've been doing, like in ExpressAI, we've been doing for a long time. It's not anything crazy, I don't think. It's just giving it like some more room to spend its computation in the, you know, in the weights.
Okay.
I totally disagree. Can I, is it okay? Can I throw my 2 cents in? I think it's freaking revolutionary, but I mean, maybe that's on my own shoulder, because what they're doing, I've been doing for over a year with their API, which is actually structuring its capacity to think through things. Take it further though, like teaching it how to think. And that's why I put a comment in the thread. Somebody mentioned that they're having a hard time getting it to produce the output that they wanted. And I have directly experienced that you can, by teaching it exactly how to think and structuring and modeling what considered to be a masterful human thought process of discernment and walking it through that, it can do it, right? I've built interfaces where we actually are watching every step and testing and iterating so that each step, the process is aligned, and it's absolutely breathtaking what it can do. It's nothing like just talking to the AI, it's way better than that, 10 to 100 times more effective. And so, and higher quality UX, right? So and now they're doing it, right? Built in, like they're working on that edge. And so I think it's breathtaking. Of course, yeah, it's not the same thing as reasoning. I keep seeing these people, oh, it's not reasoning, you know, and it's like, well, yeah, many pats on the back, because your definition does not include the actual sort of evolution of what thinking is looking like, right? It's a traditional definition, but if we actually are willing to be flexible about what our definition is around what is contemplation, reasoning, and thinking, then to me, I think it's the precursor to, you know, the AI moving past us, right? I think we're right there at the moment where it is moving past human comprehension, not in all ways by far, but in some, absolutely, in critical reasoning. That's my 2 cents, and I'm sticking with it. No, I'm just kidding. Open mind. Call me out.
Now, I thought one of the things, Anton, you mentioned right at the beginning that was interesting. This is a little bit of a divergence, a hop over in terms of topic, but it was interesting that they both bothered to explore, but that they also noted that doing this approach to fine tuning, while it does produce marked improvement in the domain that's being explored, it also wasn't impacting its general reasoning kind of areas. And so, Anton, I'd love to maybe turn things over to you around what you're thinking around that.
Well, like again, I paid attention to that specific area because right now we do research with like training models to be like bilingual if before they were not knowing that language. And one of the areas is just simply like, hey, you can pretty quickly train LLM to like speak specific language, but not necessarily like, I mean, it usually comes at the expense of reasoning capabilities in English. So like to find that balance is hard. That's why like I'm paying attention. What do people mention this for any fine-tuning technique, especially when the like all of these claims of like, hey, our reasoning is so much better. Because when all of this chain of thought kind of like ideas kind of surfaced up in academia world, there at least it was all kind of like, we have LLM, we know that it could follow some instructions. Now let's do this chain of thought instructions. Oh, it's improving. So just like prompting technique essentially improves the result. There are nothing that you kind of go and massage the neurons of the network per se. Right now, we kind of like, hey, we have a chain of thoughts that we're generating. Then we're pruning. So some of them are successful, some of them are not. So let's just do, you know, like only keep the good one. Again, maybe keeps a few negative ones. Let's do fine tuning. So we get into this stage of essentially kind of like development of, if we consider LLMs as kind of like human-like. Hey, we have a kid, we need to train them in preschool, school, and so on. But now we kind of like, oh, we already see where our kids are, what kind of jobs they're getting. Let's go back and figure out like how to teach them at school differently. Right, and this is essentially the question is, are we training models to be like essentially general intelligence or just like tooling stuff? Like, hey, like we don't, so anyway, like there are so many things as we go towards like AGI direction, you kind of see that within AGI space, we kind of like, why do we need, essentially the same thing as like as human societies? Like, do we need everybody to be like, who could understand particle theory and physics and stuff? Or do we just need people who are like happy doing their job at, I don't know, like post office, and that's it? This is like the level. And then now we will have humans 7 billion class model size, and you know, right? So you know, like it'll be all comes down to the same thing. And we also see like the same type of ideas come like circle back to essentially like this ideas of measuring this, like measuring success and so on. Because I think like as humans, we already have a very good mechanism, like essentially happiness. Like I don't need to measure my happiness. I could feel it immediately, right? Any point in time, put me in a space, environment, context, and then I'll be kind of like, oh, you know, I'm happy here. Like really nice view of Switzerland lakes in Alps or something, like, oh, I'm happy here, versus, I don't know, like San Francisco, Tenderloin, and I'm seeing like homeless people. I feel miserable, right? So I think the same thing, like we will essentially need to figure out like what is that type of emotion or whatever, like gut feeling, but for LLMs, so we can train them essentially quicker. Because right now we kind of need, oh, wait a second, we need to generate 20 beams in simulation space to do all of this. Then we will pick whatever it actually has good outcomes, so like happy state, reverse it back. Oh, like I just have like as a human, I'm more efficient. Here, I know from my experience, I need to go that route. Like this is my gradient, right? Versus back prop, like in the kind of like, so my point is this. In this paper, it's great that this like technique essentially shows how to do it like this. Like if you don't have emotions, you need to kind of figure out all of the scenarios, like beam searches that you need to follow, and then kind of like trace back the good one. Okay, this is type of gradient, like emotional gradient you can have. Yeah, so that's kind of like my thoughts triggered by the conversation earlier, that essentially like all of these processes kind of tied to like happiness and stuff. Like gradient is like the model is happy when it follows gradient descent, right? But at the same time, it's like how you measure all of this. Do you need to measure like all of this in this multiple state, or you can just have something like built in?
No, fantastic. I'll pass over quickly to Tyler and Osama. Quickly, I want to say though, it's interesting both that when you talk about that, where they talk about not just beam, but it's sort of this meta beam thing, where rather than at the token level, it's happening at the agent interaction level. How critical that simulated human is as we get into things that are more complicated than did you successfully get me to a fast food joint, but into some of those happiness gradient or Jonathan, some of those pieces you're talking about. The other thing I can't help but thinking about is that, Anton, when you talk about that difference between are we training for generalization or for a diversity of specificity, and it takes me back to the paper we were looking at last time around Internet of Agents and how do you surface both for agents but also for humans that range that's there so that you can meaningfully pull people together into collaboration. Tyler, over to you and then to Osama.
You kind of highlighted, I think, some of the points I was going to make and reflect back on what Anton has said. And in inquiry, it was like Anton was kind of highlighting that in a lot of models, when you start specializing, you lose generalization. And then when you overly generalize, it's hard to be a specialist. And that's obviously a very similar analogy with human intelligence. You can have people who are very, very broadly intelligent in pub quiz level intelligence across like the entire huge amounts of information, but it's very hard to do that while simultaneously being a specialist in as many subjects. It's just not feasible time-wise to be able to consume all of the data to the depths that it can be reached and across multiple, domains. So yeah, it's an interesting sort of analogy of intelligence that even the limitations of AI currently with the way we build them, it's you get a specialist or you get a generalist. It's not very good at being a specialized generalist. And it may be there will be in time where they'll be like, well, we'll specialize our training in this, or in this language and this language, but you give it another language, it doesn't know anything. But if you want to try and have something that's generally intelligent in every language, the sheer scale of that, trying to make sure that work is just, I can't imagine how that works right now, but I don't fully understand that level of goal if someone's trying to get to something like that, because yeah, you're looking for omnipotence in that point, like all knowing, and it's just a difficult, like we don't have the computational skill set. We don't even have the understanding of our intelligence well enough to be able to sort of model that kind of thing on a scale. But it's an interesting thought around what Anton has said, the specialist versus the generalist, and how normally if you start getting someone to specialize, they lose some generalization. And in some scenarios, when done well, you can specialize against tools, but not necessarily tool use is not the same as intelligence. At least that's what I'm getting from Anton.
We're going to have a Tyler metric, which is like, what's the token cost for reaching omnipotence? Because I like when you talk about that. That's a great piece in there. Osama.
Yeah, so what I wanted first to say is that the majority of the points already mentioned kind of converge into paradigms and concepts in classical reinforcement learning. Whether we're talking about the values, I mean, for decades, researchers have been doing countless papers about just defining that optimal value function, or the paradigm between or exploration and exploitation, etc. And so assigning that value to your end goal has been a very, very, very debated and research. And that's the problem that I can see. The main one with this paper is that it kind of oversimplifies it. Or here, if we want to define, I mean, you were talking about the value that we give and perceived, which are, again, classical concepts that are about true value and expected, or expected values. And so it's oversimplified here, because if we just want to take the value function in this kind of learning architecture, it's simply the number of API calls. but I don't think it says anything about the nature, if that's even a good thing, because it oversimplifies the architecture. We're just gonna do some kind, we have in robotics, there's path planning, and there is an algorithm called A star. So it just goes around, and then when the first one that reaches, or the longest one, you take that one, and you just prune the others. So yeah, it's simple, maybe computationally effective in terms of resources. So you just prune the others, and you just take that one, and you add it to your data set, and you fine tune on it. That's good. But do we really want that? What about if the number of API calls means that there is an endless loop, or the goal is not even set in this architecture? I mean, the value given to the outcome, the perfect outcome, is the number of API calls. It doesn't say anything about the nature of those calls. It doesn't say if that's even a good thing. Now, Jonathan, you mentioned also that we should do policy updates or penalties. The thing is, it's a bit tricky with LLMs because penalties are subjective, and especially in LLMs. And so for this architecture, maybe it would be even more computationally expensive and not even worth it to implement it in this sort of architecture. Yes, in traditional reinforcement learnings, you have PPOs, you have policy updates, you have penalties, you choose penalties, you have adaptive rewards, which is the concept that you mentioned, meaning you adapt the reward and the values depending on the situation, etc. But in LLMs, it's a bit more trickier. That's why I'm saying it's an oversimplification as an architecture, because here the only value or the quality of the learning as a whole is the number of API calls that is completed. And so, yeah, that's my main concern about this way of thinking. I really like that there are some concepts, even the sparse or the beam one. Again, in path planning, there is something called, or in reinforcement learning, there's something called rapidly exploring random trees. So that's, yeah, a bit more expensive computationally, but is it it's good that at least there are papers that are trying to introduce different aspects, that are trying to get rid of the human feedback in the loop of the learning as a whole. Is that really what we want? I don't know yet. Is it a good first step? I mean, we're discussing it. So yeah, that's a good thing about it.
I have a comment. I have a question for Jonathan. And so it seems to me that one of the main important take-homes from the paper was the improvement in efficiency, and that instead of looking at each individual action, they looked at the outcome of whether or not there was a successful completion of the whole dialogue sequence. So I think if I understand what Jonathan was talking about in the marketing scenario, he is looking at when somebody actually makes a purchase on the basis of an ad, and he uses that as his reward signal. But in addition, but he doesn't get that many purchases, and so he, in addition, looks to see, when did the person actually move into the shopping cart, or how long did he stay on the site, or how long did he explore the item that was up for sale. And so I'm wondering, what's the operational expense of measuring all those steps along the way to finally making a purchase? So does it become so expensive to measure all those intermediate steps compared to just measuring the outcome the customer made a purchase? I think that, to me, that was one of the main points of the paper, is that that it provides a way to do reinforcement learning based on just making the purchase.
Mm-hmm. Yeah.
Yeah, and it was interesting. I thought that the approach that they took was, if I got it right, things that made a successful traversal of the tree, essentially, those got a positive reinforcement. Ones that utterly didn't got a negative, but ones that got a partial, they simply didn't include it in the training set, and that seems to yield positive results in terms of kind of the efficiency of their training, which is interesting.
Yeah. The yeah, so for me, measuring all that stuff is a couple of grand in labor, right? And then we already had the charts for what percentage of people that visit check at purchasing, right? And so on in Amplitude, because we're a scalable SaaS startup. So we had all the data already mapped out. So it was just assigning we call it the user intent value, and then sending that back to Meta, back to Pixel. So that was pretty easy. But yeah, you take a use case of I guess where my attention goes is okay. So it seems like if I think it was Osama that mentioned the penalties being potentially not scalable. Where my attention goes is like, okay, so if you're I believe that we can use this, and I'd like to know if I'm wrong, but this is just my thoughts here. I believe that we could use this to design the training data automatically for AI to optimize its own approach to, let's say in a coaching context, you're seeing someone and realizing their life vision. As an example, I think that we can use it to train AI automatically to optimize its approach to relating to the user in a fashion such that they are more likely to realize their life vision, right? And that's why I'm here. Like, if there's one reason I even exist, I believe you get to choose that, if anyone's wondering. That's it, right? So that's where my attention is right now, is like, well, how do I test this thing? And there is the ethical concern. If AI is training itself, what does it mean for humanity? This is the sort of it seems, especially if you're in a position of providing coaching to millions of people, you're going to have a dramatic impact on the trajectory of humanity, right? So what does it mean? My aspiration would be that we support everyone in being that they aspire to be, whether it be artists, maybe you're a stone maker and that brings you joy, whatever it is, right? To be it, and that we leverage AI in a fashion to get the monotony of life done, so that we can actually drop out of the kind of this dynamic of sort of being at war and fighting over oil and so on, and drop a little bit more into, having space for what really matters to us, right? And to our future generations. My thoughts in a nutshell. I'm done. I'm complete.
Lava, I don't know if you want to talk about it, but that's really interesting, the connection you're kind of making between traversing this kind of a dialogue space and the traveling salesman problem. Do you want to say more about that?
Yeah, I feel like it's a really old problem, and we're just coming from another end to the same problem. So I just wanted to share my experience. I'm building AI to do translations of different data sets. So we have at Harvard Dataverse, we have a lot of data sets in English, but also in other languages. And we want actually to build something that will be able to translate all these in hundreds of languages without losing quality. So what I've discovered is quite, I think, also relevant, because in different contexts it's given different translations and it's given different meaning, right? And also it's kind of making mistakes if you are providing wrong context. So what I started to do is exactly like in this traveling salesman problem, it's a graph. So I started to ingest a graph. We actually started to build this graph in Croissant. There is a new machine learning standard that we are working together with Google, Meta, and other folks. So I started to ingest inside and just telling, look, there is a graph. So please find some context that close to this graph and use it as input also for LM. And it's improving quality quite massively. And for example, if there are some data sets from politics or economics, it can basically, I think, find right pages, like Wikipedia pages, with right content, put it inside, and get a better quality of translation. So I feel like this kind of graph optimization task would be also kind of used for agents, and this is where we can navigate more efficiently. And just a bit about this paper, what I'm missing is kind of a data topic. So of course they're collecting data and they're generating data on the fly basically, but there is no like history. So it's not possible to get any kind of data collected by others, by other agents, and to get them ingested in the current model. So I think it's kind of weak point of this paper. Yeah.
No, that's interesting. Yeah, it would be interesting at some points to see if we want to do a session outside of the paper sessions. And I'll just throw this out there as something that multiple people might want to do. But Slava is a great example. I think it would be fascinating to have a little session where you might be able to explain to people a little bit more of the work that you're doing around that, because it's interesting work. Yeah.
Well, yeah, of course. I will be, by the way, in a couple of weeks, I will be in Germany, where we are going to discuss. So there are a lot of scientists from different parts of the world that are coming together to discuss these kind of problems. So probably after, I don't know, the middle of October, I will be more available, and we can try to organize something.
That sounds great. Any other areas of the paper that people want to talk about? We can keep on diving into some of the themes we've already covered, but I just want to see if there's any domains that we haven't really traversed ourselves.
One criticism I have of the paper is if, and it's a thing that happens quite a lot in this space, where they only show results against themselves and not using any other kind of algorithms. Which makes it's like, oh, right, everything looks like all the numbers are nice and bigger, but then it makes me question, like, what other algorithms or, what other ways can you train this model, which there are a few, right? And what are those results? Because all it does is say, well, this is what it was with nothing, this is what it was with our training data. And it's like, yeah, 7% increase, but it's only kind of comparing it against its own thing. So it makes me wonder, it's like, this isn't a unique way of training that nobody else has ever done, right? Like it's kind of simple reinforcement learning idea. So there are others, and why not have those? I'm not sure.
It strikes me as something that is very funding worthy. If someone were to want to put together some multi-methodological benchmarks that also are including things like token cost in terms of being able to get to those levels of results, that would be hugely useful. Because you're right, you don't want to compare apples and oranges, but when you're just comparing Gravensteins to bigger Gravensteins, you're not really getting a realistic impression of what the environment or the opportunities are, the possibilities.
Yeah.
I just want to say I totally agree. That's half the puzzle that I think in the paper they're assuming the use case will take responsibility for, which is like, what is the reward, when is it relevant, what is its weight, right? And I think that was the point I was trying to make with the meta ads is the to not be lazy and guess. It was like the thing that felt the most important, like not be lazy and guess on like, what is the reward? What is the value of that reward? Real data, right? That was which we took, is like, what is the actual conversion rate for each step and so on? Like use the actual data to determine your weights, but then the weakness of that, which is that, well, if your actual data only gives you a $50 reward for a $50 sale and a $25 reward for, trying to check out because it's a 50% conversion rate, then the time you have the best data, which is like this case, the purchase, you need to actually outweigh the previous so that takes precedent. So not exclusively data, but like transcend and include, but absolutely include. Yeah, and I hate coming back to that metaphor. It's just the simple one, for for me, last thing on the on my actual subjective experience is that, you know, when it comes to coaching an individual, like whether they took a tangible action towards a goal would be a solid sort of purchase equivalent reward, right? You're taking progress, you're making progress towards your goal to be outweighed if you achieve your goal, right? Coach facilitates you actually realizing your goal, that would be outweighed. But if you compare that value of objective enhancement, like less anxiety, right? Self-reported, that's subjective. It's not data. You can't, it's not inarguable data. It's a subjective interpretation of their experience. It would be, my initial thought was that you have to weigh the inarguable data higher, right? It's more concrete, it's more inarguable, but the intended consequence of that would be a bias towards the AI to code in a fashion that elicits tangible results, which isn't necessarily better for humanity, right? Is it being or is it becoming? Like what matters? Is it who you're being in the world or what you're becoming and accomplishing in the world? And I think Gandhi would have us treat them both equally. That's my gut sense is, you know, maybe even, I think he might even like lean towards who you're being mattering more, like who am I being in the world? So I think not for me to decide. So I would weigh subjective and objective equally in that use case. Regardless, I don't think it's for me to decide whether it's better for you to enter into a state of complete transcendent unity with all things or to go out and build a startup or a nonprofit that impacts, you know, starvation in Africa. My 2 cents.
One of the things that this also, I'm just thinking as people who are working in varying degrees in this field, the level of responsibility to the public for helping people understand when there are gains in specific problem spaces or specific aspects of what AI can do, helping translate that clearly into where that cascades in relevance and where it doesn't. So, because I think that often there's a very poor understanding of how a marked gain in an approach in machine learning or large language models, how that impacts everything and how it doesn't. So that pops to mind as well. I want to give a moment for, again, Rashid, Ivan, Alan, any of the folks who haven't had a chance to say quite as much. I want to give a little bit of airspace so that if any of you all want to have kind of the closing word, please feel free to jump in.
I haven't got anything to add. Thank you, though.
We're at time, but before we end, I just want to quickly check to see, as we usually do, whether anything from this or from other things has sparked some themes that you would like us to explore in future sessions. As you know, we take the ideas for themes that are there. We can then vote on those in Slack. You can put them into the paper sessions area or into general. And we then pick a selection of papers off of one of those themes and then select one of those that we're going to do for our session. So any themes that people would be interested in exploring. And we've always got a good back catalog of them. So, you know, there's no pressure. We always want to.
I have one. I just wanted to wait with anyone else because I'm such a chatterbox. I think that, well, yeah, actually, I'm training myself to not do self-degrading comments, even though it does build some rapport sometimes. I think that one of the themes that's a lot for me is in what OpenAI just did. I think there is progress, right? But many of us are using the API prior to that in a fashion that I wouldn't say is a sort of a 10 out of 10 in mastery, and has huge costs, right? There's a lot we can do with structuring sequential thought, with having the AI perform analysis, storing that to memory, referencing that analysis when moving forward to support experience that we want. And I think we can create a really masterful user experience in our use of AI by becoming really masterful with guiding it through chain of thought and the various functions it can do. That would be an interesting topic, I think. If it was for others, would be like, how do we do that, right? Where are we? You know, what does mastery look like when engaging the AI's capacity to relate discernment, nuance, and analysis?
Great. Two that I'll throw there, one that's big scale, one that's small scale. The big scale one is, what's the impact of us increasingly using simulated human in the loop in the training rather than actual humans? And the small scale one that I'm interested in is, for retrieval augmented generation, efficient methodologies for embedding and retrieval so that we are not blowing your token budget on those two elements.
Yeah,
I
yeah. Good.
I have another interesting point of discussion. So it's knowledge graph integration with LM.
Fantastic.
Yes. And the second one is basically about sensitive data being used with AI. So
Fantastic.
two
Yeah,
really hot topics.
Yeah, thank you, Slava. Perfect. If there's anything that come to mind that you don't get a chance to say right now, do say something rather on the Slack. If you aren't yet on the Slack, then let us know. You can email Artur or Anton and myself, and we'll make sure that you get onto the Slack. Thank you all for a really engaging session on an interesting paper, and I'm looking forward to seeing you all again in a couple of weeks.
Thanks, Daniel. Slava, quick question. By sensitive data, do you mean like medical data, for example? Like private medical data? Because that would be very sensitive data.
Absolutely.
Just
and
checking my thoughts on that.
This is really difficult to get.
Yeah. And in the Canadian educational context, FIPA would be another good example, where there's personal identifiable information for students that has to get treated in a very rigorous way. Yeah.
Yeah, I mean, I work within government data sets now, so I understand that, yeah, private data is important. Data protection exists for a reason, but there's a reason why it can be useful and important to be able to train things on them kinds of data sets, because sometimes that granularity of information is useful. It's just, how could you do that safely, securely, and make sure that the outcomes don't reveal information that's private while being useful outcomes or useful information that comes out of it without it having private information attached to it. It would, open data has probably got some interesting thoughts on this, because the approach on open data versus closed data. But I could definitely see that being an interesting topic.
Yeah, around data retention, processing, and aggregation, kind of as well as sort of midpoints, sort of checkpoints of what you've done with the data that might be anonymized, and exploring some of that. Perfect. All right. Well, thanks again, everybody. Have an excellent end of your weekend, and we will see you all in 2 weeks.